This training video will aid TxDOT personnel inspecting the installation of a Type D electrical service. The enclosure is custom-built by a UL 508 industrial control panel shop. This type of service is not to be confused with an off-the-shelf type of service. The off-the-shelf type will not have an internal lighting contactor, enclosure-mounted photocell, or a handoff auto 3-position selector switch. Type D services are custom services that use either an unpainted stainless steel enclosure or an aluminum enclosure that is factory painted. All electrical equipment in this video was placed in an electrically safe work condition before any activities were undertaken. All services should be inspected before the service entrance conductors have been attached to the utility company's service drop conductors. This ensures that all electrical components are de-energized. TxDOT inspection personnel should comply with the department's safety policies. As per Item 7, Section 18, Electrical Requirements of the latest edition of TxDOT Standard Specification for the construction and maintenance of highway, streets, and bridges, the inspector should confirm that the installing contractor's electrician is either TxDOT certified or has a valid current journeyman or master electrician's license. Before we cover how to inspect an electrical service, let's follow the path of electrical energy through the service. As we follow this path, we will review the major components used to build an electrical service. We will also define the specific function of each component. Electrical energy from the utility company is transported over conductors from the local distribution system to the TxDOT electrical service. The utility conductors connect to the service entrance conductors at the top of the conduit riser. The conductors then pass through the utility company's billing meter. From the meter, 2 of the 3 conductors connect to the main circuit breaker in the service enclosure. The third conductor is the grounded or neutral conductor and connects to the grounding bus bar in the service enclosure. The neutral carries any unbalanced electrical current not carried by the 2 other conductors. The grounding bus bar also provides a place for the connection of neutrals, equipment grounding conductors, and the grounding electrode conductor. Circuit breakers protect conductors from excessive current. They are also used as hand-operated on-off switches. The main circuit breaker protects the illumination system's components from an electrical overload. The main circuit breaker is connected to the load center's bus bars. Electrical power from this breaker is then distributed to the bus bars. 1- and 2-pole circuit breakers are attached to the bus bars and distribute electrical energy to the electrical equipment in the field. 3 components control the lighting system: the lighting contactor, a photocell, and a 3-position selector switch called the handoff auto, or HOA switch. The lighting contactor opens and closes the electrical path of the circuit. The photocell controls the power to the lighting contactor's electromagnetic coil. The photocell is controlled by the HOA 3-position selector switch. When the photocell is placed inside the Type D electrical enclosure, one of 2 small, clear viewing windows allows sunlight to be sensed by the photocell. The lighting branch circuit breaker controlling the power to the light fixtures is powered by the load center's bus bars. Conductors run from the load side of the branch circuit breaker to the line side of the lighting contactor. From the load side of the lighting contactor, 2 conductors connect to 2 insulated blocks mounted in the enclosure, called power distribution blocks. The light circuit conductors from the field run back to the 2 power distribution blocks, completing the circuit. Electrical power flows from the utility transformer through the service drop and down through the service entrance conductors. The power moves through the meter, through the main breaker, to the bus bars of the load center. From the bus bars, the power then moves through the branch circuit breakers, through the lighting contactor, through the power distribution blocks, and out to the light fixtures. Other electrical loads, such as traffic signals, have power passed to them by branch circuit breakers that bypass the lighting contactor. These circuits do not pass through the lighting contactor and remain energized as long as their breaker is turned on. These electrical parts are placed inside the enclosure. To restrict unauthorized people from touching these energized components, a lock is placed on the enclosure door. With our review of how a service works now completed, let's address inspection of a Type D electrical service in more detail. For each job and location, the engineer has designed a specific type and size of service, the details of which are described by each service's descriptive code. The inspector must consult the job's plan sheets to find the data specific to that individual service. Service data can be located on the electrical service data chart and other pages of the job's plans. The type of electrical service is independent of the support structure it is mounted on. Electrical service equipment can be supported by either a timber pole, granite concrete pole, steel frame, or a pedestal enclosure on a concrete foundation. Some electrical services are connected to overhead service drop conductors, designated by the letter O in the service descriptive code. Other electrical services may be connected to underground service lateral conductors, designated by the letter U in the service descriptive code. The conductors that connect from the utility transformer near the top of the utility pole to the conductors coming out of the weatherhead are called service drop conductors. The National Electrical Code, NEC, specifies that the lowest point these conductors can be above finished grade is 10 feet. Where the space under these overhead conductors is wide enough to allow vehicular traffic, such as a residential driveway that is not subject to truck traffic, the clearance must be at least 12 feet above finished grade. Where they cross over commercial property, a right-of-way that is subject to agricultural equipment, such as mowers or truck traffic, the clearance must be at least 18 feet. The weatherhead is to be placed between 2 to 6 inches from the top of the support structure. A visual estimate of this distance can be made by the inspector from the ground. ED6 specifies that 2 of the service entrance conductors be re-identified with colored phasing tape, 1 white and 1 red. It is required that the tape cover 6 inches of the conductor's insulation. ED3 states that conductors 6 American wire gauge AWG and smaller shall have the correct jacket color. Service entrance conductors size 6 AWG and smaller require 1 conductor to have a continuous red jacket and 1 to have a continuous white jacket. The third conductor is normally black. If the service entrance conductors are 4 AWG and larger, colored phasing tape may be used. ED3B Construction Methods, Note 2, specifies that these conductors be between 12 and 18 inches in length where they exit the weatherhead. The conduit connecting to the weatherhead is called the service entrance conduit, or the conduit riser. This conduit contains the service entrance conductors, the service drop, the weatherhead, and the service entrance conduit will only be provided when the service descriptive code calls for an overhead service designated by the letter O in the descriptive code. When the service descriptive code has the letter U in the last spot of the code, the service conductors connecting to the utility company transformer are to be routed underground. These conductors are called the underground service laterals. The size of the conduit, either above ground at the service support structure or underground, will be as called for on the plans. The inspector must confirm that the correct material type and size was installed. The size of the conduit is shown on the electrical service data chart for that service's location in the plan set. The required size of the conductors contained in either the underground service lateral or the service entrance conduit can be determined from the service data chart in the plan set. Those are found in the 5th column of the chart under the title Service Conductors, Number and Size, To verify that the proper size of conductors was installed according to plans, the inspector will find the size of the insulated electrical conductor by locating the AWG size printed in small letters on the conductor's insulated jacket. Next, we will inspect the utility company's electric meter socket enclosure. The meter socket, or meter base, is installed during construction of the electrical service. The inspector will need to visually confirm that all of the conductor strands are under the retaining lugs and properly torqued. The utility company will confirm proper torque of the top 3 conductors. The inspector should confirm that the 3 lower conductors have been properly torqued. This item may not be able to be checked if the meter is already installed. The torque wrench for this inspection task is to be provided and operated by the installing contractor. The NEC requires that electrical enclosures located outdoors have conduits installed in such a manner that water will not enter the enclosure. TxDOT requires that either a threaded meter hub or a Myers hub be used for these types of conduit to enclosure connections. Let's now review the schematic drawing found on ED6. The schematic's legend is located on the lower center of ED6. First, we will inspect the service enclosure, noted on the schematic as item number 3. On ED5, the service descriptive code legend shows that this enclosure can be made of either stainless steel or aluminum material. A Type D enclosure can be made of galvanized steel, but only if it is an off-the-shelf type of enclosure. This equipment does not have internal parts, such as a photocell, lighting contactor, and handoff auto switch that a custom Type D might have. As stated in TxDOT's Departmental Material Specification DMS 11080, all enclosures except custom Type A pole-mounted service enclosures must have a dead front trim properly installed. The inspector should confirm that this specification is met. A dead front cover is a feature on many pieces of electrical equipment. A dead front ensures that personnel do not accidentally contact potentially deadly electrical components. The inspector will need to look at the electrical service data chart in the plan set to determine the physical size and type of material for each service. The enclosure's purpose is to provide protection from the weather for the electrical parts and to keep unauthorized persons away from potentially dangerous electrical energy. The next item of inspection will be the mounting and securing of the enclosure to the support structure. When a timber pole is called for by the descriptive code, the pole is to be notched or gained in accordance with the details listed in the upper left corner of ED10. Stacking of struts is not permitted. There are several other support structures that can be specified by the engineer, and the inspector must review the requirements of each individually. This information can be found on the project's plan sheets on ED Standards 5, 7, 8, 9, and 10, and in TxDOT Departmental Materials Specification DMS 11080, Electrical Services. The inspector will need to confirm that the clear working space in front of the service required by the NEC has been provided, and that there are no obstructions in the work area in front of the service. The inspector should also confirm that the door can be opened to at least a 130-degree angle and is provided with a mechanical means to keep the door held open, as required by DMS 11080 Electrical Services. All service enclosures are to be provided with an OSHA high-voltage label on the exterior surface of the door, along with an arc flash warning label, as required by the NEC. The enclosure must also be labeled to indicate the unique service ID, as shown on the electrical service data chart in the plans, and the type of load served. The enclosure door is equipped with a padlock for security. DMS 11080 and Standard Sheet ED5 Electrical Service Notes, Note 5, require that the contractor install a padlock keyed for a master number 2195 lock before the service is energized. In the enclosure data pocket, The inspector should find laminated panel component layout sheets provided by the UL 508 shop. The inspector should locate the main circuit breaker on the laminated drawing and compare the ampere rating to what the plans call for on the electrical service data chart for that service. The legend on standard sheet ED6 identifies the main disconnect breaker with the number 4. Before power is applied to any electrical equipment, and before the contractor places any circuit breaker in the on position, the system's voltage must be verified. This is done by taking readings with a known good voltmeter, provided and operated by the contractor personnel. This important data should be recorded in the presence of either the engineer or the project's electrical inspector. On this 120-240 volt service, line-to-line voltage is 240 volts. On the same 120-240 volt service, testing either line 1 or line 2 to neutral, the reading should be 1/2 of 240 volts, which is 120 volts, allowing plus or minus 5%. The Type D service is required by the plans to be built only by a UL-listed industrial control panel shop. A label with the shop information must be attached to the inside of the door. This label should clearly show the name, location, and phone number of the shop, the UL file number of the 508 shop, the shop order or drawing number, the date of manufacture or assembly, and the line voltage. The panel must have the words "suitable only for use as service equipment" clearly printed on a label attached to the panel's door. DMS 11080 requires that a document pocket be attached to the inside of this door. It also specifies that a set of laminated drawings be placed in this pocket. The inspector will need to confirm that a laminated sheet showing the wiring diagram from the UL 508 shop has been provided and is in the document pocket. The UL 508 shop must also include a laminated plan sheet from the project with the electrical service data chart used to build the enclosure shown on it. Other documents required are the electrical plan sheets, redlined with any changes made in the field, reduced to 8.5 by 11 inches, and laminated. These plan sheets should show the location of every branch circuit from beginning to end that is fed from the electrical service that is being inspected. These drawings will help maintenance personnel troubleshoot the system in the future. Next, the inspector should inspect the branch circuit breakers. The ampere rating of each branch circuit breaker and the specific load served should be confirmed by a review of the panel's schematic diagram. The ampere rating for each circuit breaker is printed on the end of the breaker's operating handle. The Type D service with a load center will have plug-in type breakers, commonly called stab lock. Plug-in stab lock type breakers are sometimes incorrectly installed. If they are not fully connected to the bus bars, they will not operate properly. Any breaker with a part that is found to be broken, cracked, or showing signs of overheating must be replaced by the contractor immediately. Each breaker must be marked with the load served. To comply with this requirement, a circuit directory is required to be correctly filled in. The inspector should confirm that a single-pole 15-amp breaker provides power for the lighting control circuit. The ampere rating and number of poles for each branch circuit breaker should be confirmed by reference to the electrical service data chart. Next, the inspector should inspect the lighting contactor. The lighting contactor is a magnetically operated switch that opens and closes the circuit to the light fixtures. The ampere rating and number of poles can be found on the electrical service data sheet. The brand and model number for the contactor is on the unique line drawings sent with the enclosure by the UL 508 shop. Next, the inspector should inspect the handoff auto switch. The handoff auto switch controls both the manual and automatic nighttime operation of the lighting contactor. After electrical power has been turned on to the service, the inspector should place this switch in the hand position and confirm operation of all lights. Upon completion of this task, the handoff auto switch should be returned to the auto position. To reduce the number of conductors connected to the lighting contactor, power distribution blocks are installed. Power distribution blocks allow conductors from the lighting contactor to be connected to a common point so that power can be fed from the lighting contactor to multiple luminaires. The blocks are noted on the panel layout diagram and should also be marked within the panel. The inspector should visually confirm that each conductor is held tightly under its screw and that none of the conductor strands have been cut off or damaged. A light-sensitive photocell switch is used to turn the lights on at dusk and off at dawn. The photocell can be located either on the service support structure or within the enclosure itself. The inspector will need to review the descriptive code for the service being inspected to determine the photocell's specified location. When the photocell is specified to be installed within the service enclosure, the UL panel shop should provide 2 photocell viewing windows, one on each side of the enclosure. These windows allow for quick and easy field relocation of the photocell if a local light source interferes with proper operation of the photocell. The photocell is attached to a special receptacle that facilitates quick replacement. To inspect a photocell mounted in the enclosure, the inspector can remove it by rotating its housing and then pulling up and out of the socket. Once removed from the socket, the inspector can then locate the part number and the manufacturer's name on the device. This can be compared to the approved photocell part numbers on TxDOT's pre-qualified materials producers list. After verification, the inspector should then reinstall the photocell and rotate it until it locks into the socket. The Type D service is shown on the schematic diagram with a single bus bar, to which is connected the grounded service entrance conductor, also called the neutral conductor. All white insulated neutrals from the branch circuits will also be connected to the bar. The electrical service grounding electrode conductor will also be connected to the bus bar. This is a solid number 6 AWG bare copper conductor, the other end of which is connected to the ground rod or to the steel support pole itself. All equipment grounding conductors will also be terminated to this bus. The NEC requires a green-headed main bonding screw to bond the bus bar to the enclosure. The bus bar must have a label near it listing the correct torque value for the screws that secure each conductor to the bus bar. The torque value should be verified by the installing contractor. The inspector should examine each conductor to confirm it is secure and undamaged. A Type D service will have some loads, such as a signal cabinet or flashing beacon operating at 120 volts. Each 120-volt circuit in a Type D service will include a conductor with a white-colored insulation. As can be seen in the schematic diagram, white and green insulated conductors and bare copper conductors will all be connected to the grounding bus bar. Let's now review an inspector's checklist for the Type D electrical service. Overhead service drop is secured below the weatherhead, and proper conductor vertical clearance has been provided. Weatherhead height and material is correct, and the plastic insert has been installed with the individual conductors exiting separate openings. Service riser conduit is rigid metal conduit and is properly supported. Utility meter and base is properly installed. Enclosure is correctly mounted in a neat and workmanlike manner. Enclosure material type is as shown on the electrical service data chart in the plan set. Enclosure is properly labeled on the exterior door. The danger, high voltage, and arc flash warning labels, as well as the unique service ID and type of load served. UL 508 shop labels are applied and data is correct. Document pocket is as specified and contains required laminated drawings from the UL 508 shop, as well as laminated red-lined plan sheets to be supplied by the installing contractor towards the end of the project. The dead front trim is properly installed. Lockable door handle has a padlock keyed 2195 installed on it. Voltage readings are correct and within tolerances. Main and branch circuit breaker sizes are as specified. Branch circuit conductors are properly identified as to the circuits and are terminated correctly. Photocell brand and model is as specified, and 2 viewing windows have been installed. Lighting contactor ampere rating is as specified. Handoff auto switch is functioning properly. Conduit grounding bushings are installed on all metal conduit. Conduits fed from underground are sealed. Conductors have passed Megger testing as required by Item 620 of the TxDOT Standards and Specifications book. Ground rods of correct size and length have been properly installed. Concrete encased grounding electrode was properly connected to steel support poles anchor bolts. Service support structure is as specified. This completes our review of the inspection of the Type D electrical service.